In demonstration, now this is the latest part of the syllabus added, that is the sound. In demonstration, the teacher uses a loud ticking clock on two hollow cylinders, A and B barrier, a smooth surface. The clock is used as sound source. Figure shows tube A and tube and the clock both fixed in position on the left of the barrier. Sound from the ticking clock passes along the tube A and is incident on the smooth surface. A student listens to the sound passing along B, which is on the right of the barrier. On the tube, draw a position of the sound here by the student loudest. तो position कहाँ होगी जहाँ पे आपका this angle of incidence और angle of reflection equal तकरीबन होगा, वहां से आपको loudest sound सुनाई देगी. ठीक है. So the next part, explain your answer to one reflected sound is loudest when angle of incidence is equal to angle of reflection. Speed of sound in typically speed of sound in solid 5000 meter per second. Already know that the range आपके पास 2000 meter per second to already discuss above in above question 8000 meter per second. Okay, a microphone is connected to a cathode ray oscilloscope. Again, the cathode ray oscilloscope, a note produced by a musical instrument cause the trace on the screen. This the trace is stored electronically in the CRO. Calculate the frequency. Now the frequency, we note that frequency of this note. Note means the sound of particular frequency and wavelength is known as the note. Note is also the sound basically. Sound with particular wavelength and frequency is known as note. One is 0.20 milliseconds per division. So we have this CRO. So CRO, so we have to check the frequency. So first we have to find the time period. Remember, frequency never calculated direct from the CRO. From the CRO, we are able to calculate the time period. Or amplitude, we are can directly calculate the time period and amplitude. So for the frequency time period, so in this four complete box, one complete wave is found in four complete box, and the value of one box is 0.2 millisecond. So the first we write the formula. The frequency is equal to 1 divided by time period. So 1 divided by time period is, that is four boxes. 4 multiplied by 0.2, which is equal to 1 divided by 4 multiplied by 0.2, that is 0.8. 1 divided by 0.8, so that is the 1.25. Okay. First you convert this 0.2 into 10 to the power minus 3, because the millisecond again convert into the second. So 1 divided by 0.2 exponent minus 3, that will be 1 divided by 8 exponent minus 3. So that is the answer is 125 hertz. A note from a second musical instrument played and trace as produce new note also displayed on the screen. Figure shows a screen display both original and note. Okay, in each of three spaces below, draw a similar or difference between the sound made by the two notes. Okay, now you see this, that the amplitude of one wave is different, pitch is same, time period is same, because this wave, S wave, is this is one complete wave. This is one complete wave. Crust then two small crusts, then we have a trough. Crust, then two small crusts, then we have a trough. So this is one complete wave. So, and this is also one complete wave. The original note is also one complete wave. So the time period is same because the horizontally represent the time scale. So time period is same and amplitude is different. And the third one is that shape is also different. So, so the different is we have original trace and S. So original trace is louder than S. Remember that we do not here to write the amplitude of the wave. Original wave is higher than the S because we are discussing about sound, not the wave property of sound. So careful that they are highlighted in the more bold fonts sound. It means that we have to discuss the characteristic of sound, not the characteristic of sound wave. So original trace is louder. The second difference is that quality is different. Quality or timbre already discussed. That is the shape of the wave is different. Is different. We are not writing the shape of the wave is different because we are discussing is different. Time period is time period. Pitch of sound is same. Pitch of sound is same. Time period is same. Okay, a physics textbook states that sound is a longitudinal pressure waves with the frequency with the audible range displacement is meant by longitudinal wave. Again, repeated question. Wave in which particle of medium oscillate parallel to the direction of wave travel. Highest frequency audible range 20,000 hertz and the lowest frequency is 20 hertz. The speed of sound in air used on to calculate the shortest wavelength. Shortest wavelength means highest frequency. So V is equal to F lambda. So lambda is equal to V by F. If this is the highest, this is the lowest. So the highest frequency V is 330 and divided by 20,000. So the wavelength is 0.0165 meter. So answer is three significant figure. Okay. Two significant figure. Okay. Device used to reflection of ultrasound to measure the distance, ultrasound, frequency of sound. Above 20 kilohertz. Now the person is measuring the distance from wall to wall, distance between the walls. That wave reflect from opposite wall. Time sending the pulse is this. Airspeed is the distance between the opposite wall. So remember that V is equal to 2d by t. So d is equal to V multiplied by t divided by 2. So V is 340 multiplied by t is 0.03 divided by 2. That is the 5.1 meter. Audible sound waves and ultrasound wave both consist of compression and rarefaction. One difference between compression and rarefaction. So compression in compression, molecules are very close to each other. In rarefaction, molecules are far apart from each other. In particular medium, the speed of audible sound and ultrasound wave is V. State the equation that relates the wavelength and sound wave to its frequency. V is equal to f lambda. Explain how this in this medium wavelength audible to the sound compares with the wavelength of ultrasound. Okay, wavelength of audible sound is greater than ultrasound because ultrasound frequency is greater than audible frequency. As lambda is inversely proportional to frequency. Describe one use of ultrasound wave. Now, I detail explain the ultrasound wave. There are many uses, but I here to explain the is used for cleaning objects, cleaning jewelry or objects. So this application is also asked in letter question. So we have to write here, then we see that question is also asking in there. Used for cleaning objects, place object into the ultrasonic, place the immersed object into the ultrasonic liquid solution then falls ultrasound waves on the surface of on the solution. Solution vibrate at very high frequency as well as object. As a result, dirt is shaken off. So that is 3 marks valid for this detailed solution is valid for the 3 marks and as well as for 2 marks. So all the things are clear. Okay, now we have the bell jar. Again, we have the bell jar. What is the frequency of sound? Vibrations produced per unit time. Per unit time. Okay, the speed of sound is calculate the wavelength V is equal to F lambda. Lambda is equal to V divided by F. So lambda is equal to V is 330 divided by F is 2000 2200. So that is the 0.15 meter. The sound passes from air into the glass. State what happens to the frequency of sound. Here we have remember that as sound passes from less dense region to the denser region, so its speed increases because sound travel faster in denser medium. So frequency remains same, remains constant, and the speed of sound increases. So sound has traveled from less dense to denser, so it bends away from the normal because speed of sound increases. Wavelength increases, speed increases, it bends away from the normal. It is the reverse case of the light. As the light travels from less dense to denser, so speed of sound decreases, wavelength decreases, light bend towards the normal, but in case of sound, it bends away from the normal because speed of sound in air is slowest and the solid is largest. Describe how sound is produced by loudspeaker. So there is a cone is connected in the paper cone is connected in the loudspeaker. So it vibrates as the vibrates. So what will happen? They also vibrates the air molecules which is contact with it. As the cone of loudspeaker vibrates, as the cone of loudspeaker vibrates, air particles contact with it also oscillates parallel to the direction of wave travel. Okay, how the sound is transmitted through the air. As the cone oscillates, cone of loudspeaker oscillates, air particle also oscillates. Parallel to the direction of wave travel. As a result, series of compression and rarefaction is produced. Action is produced. Series of compression and rarefaction is produced. So energy transfer due to the oscillations of particle. A pump connected to the tube bell jar pump is explained why the volume of sound decreases. There is less air left inside the jar. So less sound energy transfer from one point from one point to other. Explain what is meant by ultrasound frequency of sound above 20 kilohertz. Explain briefly how ultrasound can be used in prenatal scanning. Now this is the application. Ultrasound pulses falls on the fetus. Ultrasound pulses reflected from the different LA layer of tissues. These reflected pulses fed into computer by a detector where it forms 3D image of fetus. Echo reflection of sound. what happens to the amplitude of sound wave? The pitch of echo is same as that of the original sound, not loud. Amplitude of sound wave, that is, decreases, constant, not change. V is equal to f lambda. Lambda is equal to V divided by f. So 330 divided by the frequency. How much is the frequency? 37 hertz. Three thirty divided by 37. So calculation, I think so 0.8.9 into 10⁻³ इसको चेक कर लीजिएगा कि मुझे कैलकुलेटर पे सही आंसर नहीं आया।